Okay, so today we're learning derivative of a function. The definition of derivative. The derivative of a function f is defined by f prime. So this little sign there, we call this a prime. Okay, or if you want to in English, it's a little apostrophe. Okay, it's not a 1. Okay, it's prime. Okay, f prime of x is equal to the limit of h approaching 0 and the following appear. Now, if you remember, we have studied this in the past, right there. And then we found that this is the slope, okay, of a line, okay? But the slope of a line is called the derivative, which is f prime right there. Now, we say it's f first prime, okay? In the future we're going to list f double prime in the future, okay? Provided this limit exists, okay? Now, we have different notation in calculus that you're going to have to be acquainted with because it depends the author of the book. Some author may approach it in a more old fashion, okay, or newer fashion, okay, depend. And you have the f derivative as the following that represent the derivative. Or we say dy dx, okay, or we just say derivative of x. Now dy dx, okay, stands for the change in y over the change in x. Well, it looks like slope to me, right? Okay, if it's a change in y with change in x, represents the slope, which is that, so it's the derivative. Okay. Now let's do a question here. Example 1, given a simple function 3x minus 7, find the first derivative. Okay, find the first derivative. So how do we do that? Okay, first we apply the definition I just gave you earlier. I give a definition to be as following. Okay, so you write down the definition over again. And next, you had to apply what we call the limit approach. And remember, is to go ahead and substitute whatever is in this function into the function itself right there, and which becomes as the following. And as I mentioned to you in the past, f of x doesn't change. Still 3x minus 7. But remember, it's critical to add parentheses because we have a negative sign at this time. And h goes back down there. Now, at this point, remember, we explained to you in the past that this is calculus. And now we're doing the meat of the hamburger, which is algebra. Okay? So let me move this forward there. Okay? And what you see there is like I distribute the 3 into this expression right there, which is x plus h, and which become 3x plus 3h minus 7. And the negative is also distributed between in this function, actually expression, which become minus 3x, and minus becomes plus 7. Now, as I mentioned also in the past, that this is the place where hopefully you will have things that cancels out, right? Okay, well, look, I see 3x, I see 3x, I see 7, and I see another 7, and I see an h and an h. Nice, okay? So I guess we're left only with that 3 up here, okay? So the derivative is 3. Okay? Because if you remember, we take the limit of a constant is the constant itself, right? Done. I don't think that was very complicated, okay? Okay, let's do another one. And this one up here is the square root. So example 2 here, you have f of x, which is the square root of x, but this time you're looking for the derivative of y. Okay, I'm going to explain in about a couple of seconds right there what I mean by that. So please remember in the past that you have learned at y equal to f of x, right? We know that so far, right? So we could do the same thing for the derivative. The first derivative must be equal to this 2. You see this? Makes sense, right? Okay. So let's go ahead and do this one too. Okay, that takes a little bit of steps. So it became as the following. Okay. So remember, you want to substitute the information x plus h into the radical, which is the square root of x, right? And became as the following right there. And you have to take what we call the conjugate, right? And we did this a million times already, so it should not be a surprise to you. Okay, and then at this time we are taking care of the algebra. Okay, so it becomes as the following, as we did this again many times. So what I did there, I multiply, I've applied the FOIL method, which is this times that, and this times this, and this times that, and which become the following on the top. Okay. And in this case here, hopefully we have things to cancel out, and I think I can see some stuff up here. Okay. Okay, so x, and this x goes away. Yes? You realize that also all these terms right there, the square root of x times the square root of x plus h minus the same thing becomes 0. So I put an arrow, goes to 0. Okay? Then you have h, and then h goes away too. So technically you're left with a 1 at the top. Okay? And this is the bottom up here, which is 1 over the square root of x plus h plus the square root of x. Okay? Remember, you haven't taken the limit yet. It's still there. Now it's about time to take the limit, which is h approaching 0, into my function right there. Okay? And becomes as the following, which is 1 over 2 the square root of x. Because remember, if 0 goes into h, so you got square root of x plus square root of x becomes 2 square root of x. And that's your derivative. Another notation, I wrote into another notation there to help you out, is a derivative of the function y, okay, with the domain for all x, such that x is greater than 0, because x cannot be a negative number down there, right? And also cannot be 0, because if it's 0, it will be undefined. So again, this is the domain, and this is true for all x such that x is greater than 0. Okay. Do I need to write this one down to help out to elaborate this thing here? Yes. So I think this over here stands say for all x, okay, such that x is greater than 0. That's what this means up here, okay? As deeper you go into mathematics, you use a lot of short notation in this form. Okay, I'm going to stop here for this time.